Welcome to the Naval TIG Tinker. My name is Mikael Sjöman, and this is currently a series on building this monster. It is 3D printed mostly, electric, 20 kilowatt or 25-ish horsepower, electric outboard. And in this episode, let me just put this away, it's kind of heavy. We're gonna speak about the fantastic Sunday that I had this weekend. It was sunny, it was finally this amazing Swedish weather, like 19 degrees plus. Yeah, it's good for being Sweden. And yeah, everything was awesome. We went out, I pulled that gas, went slow first, and then I put everything and we were just flying on the water. And that didn't happen. I was actually finishing my last pieces, for this, kind of just putting some kind of final touches to create some nice video going out. And one of the things I wanted to do was to take this carbon fiber ABS mount that I've built. So it's ABS inside, skin with carbon fiber, multiple layers. It's strong as hell. So, but I couldn't get this out because I wanted to take out I had a screw here on the other side, and I started banging it because I wanted to switch it to this one, which looks nice, stainless steel, nice. And when I did that, I was kind of holding against, so some force went into the mast of the motor I just showed, and I was banging with the hammer. And when I did that, this happened. So this is the hinge from the boat motor, so that you can flip like this to the mast of this outboard. And looky there, it just went straight off. So the reason, let's start with this. So this is the hinge from the mast to the boat, so that it can flip up and down and push in towards the boat all the force that it needs to make the boat move. And the reason I designed it in two parts was that one, I wanted to have the layer lines through this shaft that goes down in this direction because that's maximal strength. But perpendicular to this, let me just see, I have this hole, which creates a lot of stress here. I mean, pushing away from the boat, and this is pushing into the boat. When it goes like this, you can kind of see how it goes, right? So I had to print this in this direction to get maximum, maximum strength through that hole here. And that was right, that wasn't incorrect. But what I didn't know was that ABS and the epoxy I have here, you can kind of see how I almost designed it to kind of lock in place here. That delaminated. And I'm so happy it did here, because think what would have happened if I went out and this just chopped off. I would have gotten that super strong electric motor with that propeller spinning at I don't know how many thousands of RPMs per minute. Maybe straight into me and made me to this beautiful meat bag of minced meat at that point. So yeah, I'm really happy this happened here, because I absolutely do not want it to happen when I get out. So let's go into how I'm gonna fix it, because I've been thinking a lot and how to get it. So this is a new part that I printed. It took almost 25 hours. I was printing it slowly to get better layer adhesion, like 50, 60 millimeters per second. On my printer that's pretty slow, but yeah, that's still fast in some circles. I printed in ABS. You might wonder why, but I'm gonna get to that. But I did something special here. I don't know if you can see it. I printed it in this direction. And the reason for that is, let me show you. So I have this shaft going straight down, connecting the mast here. And, well, let's put the right thing in there that actually goes through here. So, yeah, we're gonna have to drill those up a little bit. So, I wanted strength in this direction first, so I had to print it in this direction. But now I made it to one part, and if I do that, then the layer lines would go like this, and this shaft would be dangerously close to being able to kind of pull out through some layer lines here. And because the layer lines would go like this then. So how do we solve this? Well, we tilt it. So the layer line goes like this, and as you can see, if I'm printing it like this, like layer by layer, it actually goes through both axes now, the printing. So it goes through around here and around this one. So it's not printed on 45 degree because then it really wouldn't hit both. But I'm printing it a little bit on the side, trying to optimize that as much as possible goes through this axis and also this axis, so they kind of lock each other in. So I think that's a good way to do it. But it got me scared. So I have brought my trusted old friend here, Mr. Carbon Fiber. So I don't trust this anyways. It's still not a lot of plastic here. It's printed not perfectly to support this one. So it gets me a bit scared. So we need to do something tonight before I go to sleep. And that is to carbon skin this. So the first thing I'm going to do is to just put a layer around here. So all the way from here, around here, and down here. So that there will be one layer going just around here. And then I'm going to carbon skin it in this direction. So that it goes all the way here and around, kind of locking everything in. So it cannot move. And you might wonder, how much strength does this give? Well, I think one layer of carbon fiber can withstand like 3,000 kilos of force, if I remember right, in tensile, pushing outwards, as long as the epoxy holds. So I'm gonna have to go like all the way around here and then around there again to kind of create a lock here, and the other direction too, just to be extra safe. So 2 layers should take 6,000 kilos of force. I don't remember how many megapascals that is, but yeah, you who know better, maybe you can write that in the comments and let me know. ChatGPT, if not, is a very good friend of that. So yeah, you can kind of see the layer lines, how I did it. You can kind of see that it's printed on the side, like this. So I've been mixing 1/3 hardener with this Dip 1 epoxyplast for about 3 minutes. And it's great to have these 3D printed things when you don't have something else to mix with. So yeah, we're just gonna put this on here. Ooh, a little bit everywhere. And then use this soft thing. This is the cheapest one there is also. And here's the nasty job, but once again, the idea is just to build the layer around to make it strong. So yeah, that looks nasty, but it's gonna look pretty cool soon, I think. And after lots of different trials, I finally got with this one with vacuumed, and I have a lot of heat coming here, like 50 degrees Celsius, better than nothing, definitely helps. So yeah, I tried these big vacuum bags, but it just won't help. So yeah, I could measure with this one that it's 54. So yeah, it's uneven, but way better than 20. Definitely helps. So we're done, right? Carbon skin this, get out, everything is gonna fly. No, I don't think so. I actually was talking with a friend and a colleague today at the office, and she came with a great idea. If you're watching this, thank you. Because we should build things that are a little bit fail-safe, especially when we're hobbyists, we're not engineers. We should try to take every precaution we can, and I've seen tons of people on YouTube saying that, you know, just get, you know, I'm an idiot. I'm quoting one guy. I really like your videos if you're watching this, but it's, yeah, calling yourself an idiot, it will still, if you don't do things well and you don't try to do it the right way, in a safe way, you will inspire others to think like, can't be that dangerous, right? Well, you could die, especially when you do high current, high voltage machines with tons of torque, power. You got to try to make it extra safe. So we're gonna strengthen this for sure to the level that I feel comfortable of actually using it. But the idea that she came up with was to create like a duct around the propeller, because after all, if it fails, maybe we should have something to protect me not becoming this meat bag of minced meat. So I'm gonna have to design a duct around this. And I don't think that will be too difficult, because actually the design I have helps me a little bit. So I already have a part here with this carbon mast. That's gonna be waste. And I put this one on here. Sadly, I epoxied it on. I was thinking maybe I should actually print another one which I just put like a screw on. Maybe I want to take it off. I'm like, no, I won't take that off. One day later, definitely gonna take it off. So I have to hammer this off. Yes, let's see how well now I have it against carbon fiber, and of course carbon fiber just sticks so well to epoxy, right? So anyways, hammer this off, take it off, and I'm gonna have to kind of build from this part I have 3D printed. It's gonna go really nice in that direction, I think, because I can just put it here and connect it to this carbon fiber tube down here. And whoop, yeah, that's okay. So that's what I'm gonna do. I'm gonna design a duct around the propeller. A lot of people use that, for example, in e-foils to make sure that, you know, if it flies up out of water, it hits them in the face, at least it's not spinning like and hitting your face. And in my case, I don't think that it's gonna hit my face, but it might make my boat sink and me to that fantastic minced meat bag I don't want to become. And then I'm gonna carbon skin that too, just to create some extra strength, because there will be a lot of water flying there. It will create some more resistance. It will become more inefficient, I think. Actually, a ducted propeller can be more efficient than non-ducted propellers, but I don't think in this application it will do that, but I don't care. Safety come first. I will definitely add that now. So for tonight, carbon skin that. Tomorrow, design the duct propeller, print it out. And who knows, maybe I will be going out next weekend. I won't even be here. I will go into the southern places called Skåne here in Sweden. Hopefully I can do this before going on vacation on Monday, where I will be going to Malaysia. So let's see where I get. I don't mind. This is tech tinkering. I love building these things. I would say I love building these things more than actually driving it, but I love sailing. I love being on the water. I love building these stuff, as I said. So I don't mind. Let's get to it and carbon skin this, and I'll show that in the next episode. And if you like my videos and you like what I'm doing, please share, like, subscribe, whatever. It's I just enjoy all the comments I'm getting from all people who notice my channel, and I can talk with like-minded people who likes to build stuff. So thanks for listening in. Have a good Swedish midsummer soon. Cheers. Bye.